Good morning again, and today is the second. By the time we know, the second month has already started. Second half of the year has already started, and today we are in the second day of the second half of the year. Whether we like it or not, time still flies. So let us see what best we can. Let's see what best we can do in this time which we have together. So yesterday and for the past few days we've been seeing some properties of the earth. Okay, we saw that geology helps us to study the surface of the earth, some of the properties of the earth, like how is soil formed. Okay, and maybe even going a little beyond, we can say that it tells us how historically earth was, how earth has been evolving with time, how earth has probably been doing a lot of good things and a lot of bad things, why some things happen, like for example, why do we have a volcanic eruption, why do we have a earthquake. And probably one of the things which we have not done is try to see what are the ways by which earthquake is probably measured, what are the ways by which earthquake is probably been assessed, and some of the things like that. Now let us for a minute think about what all we have already seen. So we saw that soil is a mixture of organic substances and inorganic substances, and if you look at soil, we call it as granular. Okay, and the other thing is actually it will become amorphous or powder like, and this is what we call as the clay basically, and each of these have different properties. So soil is actually a mixture of substances which are cohesive and non-cohesive. Now this is a new word which I am using. I will be probably coming back to this in some time, in a little later point in time. Now let us take for example one of the favorite toys of children. Okay, I am sure all of you have at least one time in your life traveled on a slippery slide. So typically what is the components of a slide? You have a ladder, so children climb up the ladder and then they slide down the ladder. Okay, now what are the things which determine the way by which you can slide? Okay, can each of you say one thing? I think Ritvik, you have not given me any answer till now. So what makes you go down a slide?
Sorry, sir.
What are the things that make you go down in a slide you can go very fast or you can go very slow. Okay, what are the things that happens that help you enjoy the slide? What are the actions, or what are the things which so action is probably the speed at which you slide down.
Sir, if you hold the railing, then you can go down on your own speed.
Slide, hold the side. Okay, when you are holding the side, what is happening? You are increasing friction. Okay, guys.
Increasing friction.
Yeah, you are increasing friction,
And
much like
controlling the speed at which you go down.
much like how we what we call as hold a rope and come down. So our friction, or your bicycle brake, or whatever you want to call, friction is increased or decreased. Okay, so when you increase the friction, that happens. Now let me ask you one more thing. Okay, what kind of clothes make you go down faster? Is it a jean, or is it something where you are having when your skin is against the slide? When do you go faster?
Just, what's the first option?
You are having a nice tight jean. You are just having bare skin, more of a bare skin. If you see small children, usually they go in shorts, right? So more of bare skin. Which is the thing which is going to help you go faster?
The jeans.
Yeah, again it is a thing which friction comes in, right? So friction is one of the very important things that help you move. Okay, Aditya, point number 2. What helps you go down a slide? Slope. Very good. So if the slope is more, or if the slope is steeper, what happens? You go Faster or slower? Huh?
Faster, sir, faster.
You go faster. In other words, to resist your or to try to go at a constant speed, at a comfortable speed, you will have to apply more friction. Am I right?
Yes, sir.
Okay. Now let us say that I am applying some oil on the slide. I am reducing the friction. This is another thing, another case which can happen. So these probably are the things that happen in a slide, and this is what happens in a slope also. Now I am going to go back again to 10th standard, okay, because I am not going to teach anything from engineering, because I know many of you have not done many of the papers in engineering. Okay. So have you heard of the parallelogram law of forces? Okay, first and foremost, maybe friction. Let us say friction. Suppose you are having, yeah, okay. Let us say, what is friction? What is friction? Have you heard of the word friction?
Sir, force that opposes the movement.
Yes, very good. Force that opposes the movement, and it is proportional to the downward force, okay, or the, what we call as the normal force. In other words, suppose your weight is say F kilonewton, that means the amount of lateral force which is generated is proportional to the friction constant. Okay. So this is a common rule. Okay. So now let us say that the soil has some mass. So this mass helps to generate the lateral force, and you will get an angle which is normally what we call as the angle of internal resistance. Angle of internal resistance. Okay. So if suppose this becomes more, automatically you will find that this slope becomes much steeper. The slope can keep on increasing or decreasing. Now one of the biggest problems which we are facing is when we are increasing this slope, many times you will find that is when you are increasing the downward value of force, the required amount of friction might not get developed. The required amount of friction might not get developed to keep the slope in a stable configuration. So typically what happens, this value of mu is a constant. Okay, this value of mu is a constant. So when the value of the force keeps on increasing, the soil tends to, I mean, like, you know, the resultant force tries to go in a steeper angle. However, the stable configuration could be here. So it means that as long as the slope formed is lower than this equilibrium, the one where, you know, like you can get equilibrium, or the critical force, the slope at which the soil just starts to slide. So as long as it's lesser than that, there is no problem. Our problem comes when this increases. Like for example, when we told that there is a cutting for a road, so typically the mountain slope would have been like this. So this portion of the mountain has been cut off, it has been removed, and this soil is most likely taken and filled over here. Now the road is formed. Now the road is formed. That means I need to provide slope protection here and here. Okay, so I think till we talked about this in maybe slightly different terms earlier, right? Now when this slope protection mechanism is not sufficient, when the slope protection mechanism is not sufficient, landslides take place. Okay, so when the so this is one of the what I call as the reasons, I mean, like, you know, things which we have to consider. So the following are some of the what we call as the typical ways by which we do it. So you can construct retaining structures using probably concrete walls, okay, or you can go for gabion walls, you can go for reinforced earthworks, and so on and so forth. Another thing they also do is they try to stabilize the soil. In other words, they know that the soil is weak, so what they do is they try to change the composition of the soil, because the internal friction and other things are properties of the soil. So you can try to change the properties of the soil, and this is called as stabilizing the soil. When you talk about stabilizing the soil, typically you will inject something like lime or some other grouting material. So essentially you just pump lime or cement, some cementitious material into the soil, making it more strong than what it was before. Okay. Now till this point, I think you should not be having any problem. Okay. So basically, when you have cuts and fills, and when you have, for example, some embanking structures, you typically have the what you call as the chance of a earthquake, of a landslide happening. Okay. Now I told that soil is a mixture of cohesive and non-cohesive materials. Soil is a mixture of cohesive and non-cohesive materials. Cohesive materials are sticky. Okay. Cohesive materials are sticky like clay. So if suppose you take some red sand or some clay and rub on your hands, you will find that it leaves a residue, it leaves a mark on your skin. So this is cohesive soil, and the other one is non-cohesive soil. Cohesive is sticky, so the other one is non-cohesive. Typically this is sand. What you see in river, what you see in beach are all sands. Usually there is a mixture of the sandy component and the clay component. So soil is very funny. When you add water, to some extent it will be beneficial. See, for example, when you add water, what happens? First thing is it displaces air. Because it displaces air, the weight increases. The weight increases. Now when the weight increases, the lateral force also increases, but it cannot increase infinitely. It cannot increase infinitely. At one point the equilibrium point is reached, and when the water goes beyond that, the lateral force or the resisting force becomes negligible. See, when you are standing, okay, let us say you are standing on a pair of roller skates. Okay. Now you will be standing like this until somebody gives you a push. When a person gives you a push, the wheels, if suppose they are rusty, they will not let you go immediately. You may displace slightly, but still you are able to be in equilibrium. Now when somebody oils these parts, that means the resistance decreases. Immediately you are starting to move. This is the case for everything. Suppose you are sitting, the downward force you exert on the chair is balanced by the upward force. If this balance is not there, typically your chair is going to break and you are going to fall down. So anyway, you would have studied for a body to be equilibrium, all the forces should be equal to 0. That is, all the horizontal force, all the vertical force, and one more thing, the turning effect produced by a force, which is moment, all of these three should be 0. Same thing happens here also. Okay. Now one of the things you would have seen is, we were talking about the what you call as when you go to the beach and you stand on the sand looks level. However, the reason why you go down when the sea water rushes in is, the water fills all the pores and does two things. One, when lots and lots of water comes, there is a thing called buoyancy. Okay. So what is buoyancy? Yeah, I think who joined late? Ishan, Ritvik, I think you joined in late. Okay, what is buoyancy? What is buoyancy? Okay, forget it. It's the apparent loss of weight experienced by the body. Now, two things happen. When water is much more, it makes the soil behave like water itself. So, the soil, when the person is pushing down, he displaces the sand next to the person. So, the soil tries to go up like this. So, because there is nothing to keep it from going upward, there is nothing to keep it from going upward. So, the man typically sinks. In fact, this was a lesson which I learnt much after my engineering. My professor joined also L&T when I was working there, Dr. Murugesan, late Dr. Murugesan. He was the one who pointed out. We would have learnt it, but you know, when you are experiencing a certain thing, you will never forget it. So, there was a problem with one of the foundations we were designing. I was thinking, why not keep the foundation at a higher level? So, that time he told, because the soil was good, John, unless you keep the foundation at a slightly lower level, the soil may take the load, but then what will happen? The soil, adjacent soil will rise up, increasing the amount of the foundation sinking. Same thing as what you experienced in the beach. So, on the other hand, suppose a lot of people are standing on both sides, you will not be able to feel the sinking action, mainly because the upheaval of the soil is arrested. Okay. Now, the same thing actually happens also when you look at what you call it. This is probably a little out of context. I am only saying little, it's not totally out of context, it's a little out of context. But when you look at landslides, the presence of water does two things. Initially, it increases weight. Okay. Then at one point, it touches the equilibrium level. After the equilibrium level, it actually starts to cause the soil to move along with it. So, at that time, it starts to cause the soil to flow, and this is a dangerous condition. Typically, we call this as seepage of water. Okay, seepage of water. So, when these conditions happen, it is very likely that the soil is likely to collapse. Any questions? Any questions till this point? So, in conclusion, when shear stress, yes, please. Yes, Aditya.
Sir, while building a building,
Yes.
so if we keep the foundation
Yes.
lower, means to make the building strong, we have to keep the foundation lower, na?
Correct. Correct. See, it is not to make the foundation stronger, it is to prevent settlement, basically settlement. Okay. So, like I was telling you, when you keep the soil may be strong enough to take the foundation, instead of the man, the foundation is there. But what is going to happen when the load increases, the soil around it starts to move. So, when this soil moves a little, more and more the soil starts to flow out, and this causes the sinking of the foundation. So, initially the foundation would have been here, the footing, the level, then it goes lower. All foundations will sink, but when it sinks excessively, you are in trouble. So, that is one of the reasons why we take the soil, the foundations lower also. Okay. Many times what will happen is the soil at a lower level is stronger. Usually the soil in the top is just, you know, rubbish which we just throw, it is all loosely packed, and you know, so these are all, and also the material which makes it up may be more of organic content which does not have high compressive strength. Of course, I am not saying always it is the case, because if clay layer is found at a slightly lower level, you will still be finding that the foundation is not strong. So, typically when we design a structure, we will take what is called as a bore log, and we do a geotechnical investigation. So, one of the things is a bore log. So, we see what is the type of soil at different levels. We do the tests on the engineering properties, and then we will get what is called as a bearing capacity of the soil, okay, how much load it can take. And typically when the foundation is designed, there is one more very important thing. It does not always mean that a bigger foundation is safer. Now, this may sound counterintuitive, but take it from me that the shape of the foundation, the founding depth, the what you call as the nature of the soil at that level, and the water table, presence of the water table will all determine the load carrying capacity of the foundation. Are you able to, I mean, like, you know, just get the key points, just keep these points in mind. Okay. So, actually the strength of foundation is based on strength of footing, or what we call as the bearing capacity is based on the size of footing, size, shape also has an important part. So rectangle or square or circle or some other thing like octagon, each of them will have different bearing capacity. So we have size, we have shape, we also have the depth at which it is founded. So depth of founding or foundation depth, and presence of water table. So when I say depth of foundation, please remember that it's also the type of material which is there in that level. Okay. Moving on. So shear stress is caused by the load. So basically soil, one of the points told was overburden. Okay. And so actually the soil weight, I'll just put it as soil weight. So when water is there, weight is automatically going to be more. When overburden is there, again that is going to be making a difference. Then if suppose you are having the right amount of water, you will find that, for example, if you go to the beach and you dig a hole or you build a castle, okay, many of you would have done constructed sand castles. I have also done sand castles. So what do? You keep the sand castle walls sufficiently wet. If you pour too much of water, the soil will flow out. If you don't have water, the sand gets blown away, right? And it just slips and falls. Nothing but a slope failure. Now what happens? You add just enough water, and then you will be able to see that the wall is actually able to stand straight. So I am putting the word presence of water. Okay. And lastly the slope. So please do not think that just because you add water, soil is going to become weak, or just because you remove water, soil is going to become weak. So it's quite a complicated, what you call as a equilibrium, state of equilibrium in which the soil is present, and that is why when any one of these things get changed, the soil slips. Okay. So this is the what you call as actually what I should say is these two are the things which resist, and this is the thing which causes slip. Okay. So when you are having a soil weight, when you are having what you call as the overburden, they cause the shearing stress. The presence of water, the slope at which the soil is heaped, cause the what we call as the resistance to movement of moisture. Okay. So guys, any questions on this point? Moving on. So one more thing which happens is, so when you find that the stress, what is the action, is greater than the resistance, there is a slip. So immediately you will say, okay, let me do some plantation. Will the roots of the plant be sufficient to hold the soil mass? If it is not so, then you will go for some engineered solution. So you will go for, like I already told, maybe construct a wall, maybe construct, maybe stabilize the soil, maybe do both. Okay. So this is probably going to be the way by which you prevent a landslide from occurring. In other words, these are the mitigating techniques. So first you know what is the cause of the landslide, then you are seeing the mitigating techniques. So it means that doing a study, you are in a position to say these are the places where a landslide is likely to occur. So if you do this, you are not going to have a problem with the landslide. Friends, as I told you earlier, there are a few things like Gabion wall, RE wall, so on and so forth. I will request you to please go and have a look at the pictures. Okay. And I will conclude this session with just adding one thing. Okay, the need for weep holes. Need for weep holes. This is a very important thing. Now, when you go through a bridge and you see a wall, it includes your subway walls, you will find that there are some rectangular holes or circular holes present. These holes are called weep holes. Okay. Now these weep holes, so when the soil is heaped on the other side and as water, now what we do is we keep these weep holes so that the water will flow out of these holes, thereby reducing the lateral force. Okay, essentially it reduces the lateral force. Okay, so whenever there is a surface, this is the normal force and this is the lateral force or shearing force. Okay, so we will reduce the water pressure and thereby ensuring that the wall is kept safe. Okay, we have had many what we call as the we have done some construction work and also seen how when the water is more, the wall or the slope protection mechanism is likely to collapse. So many times when we have not made provision for the what you call as the weep hole, we will artificially have to do that. Okay, but once you experience it, you will never make that mistake. Okay, any questions please from your side? Right, I hope you found this interesting and useful. Yeah.